Imagine looking up at the night sky and seeing something impossible. The stars begin disappearing one by one. The moon becomes almost invisible behind a gigantic blue world. And then you realize the truth. Uranus is no longer orbiting the sun. It is coming straight toward Earth at 1,000 kilometers every second. That is over 2 million miles per hour. At that speed, humanity would not have days to prepare. We would barely have minutes. So what would actually happen if Uranus, one of the largest planets in our solar system, slammed directly into Earth? Would our planet explode? Would the oceans vaporize? And could anything possibly survive? To understand how insane this scenario is, we first need to understand the size of Uranus. Uranus is roughly 4 times wider than Earth and has about 5 times Earth's mass. It is a massive ice giant surrounded by a thick atmosphere of hydrogen, helium, and methane. Unlike a rocky asteroid, Uranus is not a solid ball crashing into another solid ball. Most of the planet consists of extremely dense fluids and exotic materials under enormous pressure. But don't let that make the collision sound harmless. At 1,000 kilometers per second, the energy involved would be beyond anything humanity has ever experienced. The first problem would actually begin long before Uranus touched Earth. At that speed, Uranus would cross the distance from the Moon to Earth in only a few minutes. As it approached, its enormous gravity would begin disturbing the entire Earth-Moon system. The oceans would bulge dramatically toward the approaching planet. Earth's crust would experience enormous tidal forces. Earthquakes would begin occurring across the planet, and some of them could be stronger than anything recorded in human history. The Moon would also be in serious trouble. Uranus is more than 50 times wider than the Moon, and its gravitational influence would overwhelm the delicate balance that currently keeps the Moon in orbit around Earth. Depending on the exact trajectory, the Moon could be thrown into a completely different orbit, pulled toward Uranus, or even sent flying away from the Earth. But the terrifying part would be the speed. 1,000 kilometers per second is about 3,000 times faster than a typical commercial airplane. It is so fast that the atmosphere would barely have time to react. As Uranus entered Earth's outer atmosphere, the gases around the planet would be compressed and heated to unimaginable temperatures. A gigantic shock wave would race around the globe. The atmosphere would not simply get pushed aside. It would become violently compressed. Temperatures would rise to levels capable of turning ordinary air into plasma. The upper atmosphere would glow, expand, and begin escaping into space. The collision would effectively transform Earth's atmosphere into a gigantic furnace. And then Uranus would reach the surface. Except there might not really be a normal impact. At these speeds, the boundary between Uranus and Earth would become an enormous region of superheated matter. The kinetic energy of the collision would be converted into heat, pressure, shock waves, and gravitational disruption almost instantly. To put the scale into perspective, Earth's entire mass is around 597 sextillion metric tons. Uranus is enormously more massive. Now imagine giving that planet a velocity of 1,000 kilometers per second. Kinetic energy increases with the square of velocity, meaning that making an object move twice as fast gives it 4 times the kinetic energy. At this speed, the energy involved would be so extreme that comparing it to individual nuclear weapons becomes almost meaningless. The impact would generate a planetary-scale shock wave. Mountains would be crushed. Forests would be instantly destroyed. Cities would disappear before anyone could understand what was happening. The oceans would be violently displaced, producing enormous waves that would sweep across continents. But even that would not be the biggest problem. The crust of Earth would begin to fracture on a global scale. Gigantic portions of the planet's surface could melt. Rocks would be blasted into the atmosphere and beyond. Some material would escape Earth entirely and form a cloud of debris surrounding the planet. Other material could enter orbit, creating temporary rings made from vaporized rock, metal, and ice. and Uranus itself would not simply remain intact. At this velocity, the collision would tear both worlds apart. Uranus contains huge quantities of water, methane, and ammonia locked under extreme pressure. During the collision, these materials would be subjected to temperatures and pressures far beyond anything found naturally at Earth's surface. Some of the planet's material would become superheated vapor or plasma. The result would be less like a traditional asteroid impact, and more like two planetary bodies being violently shredded and mixed together. For Earth, the consequences would be catastrophic. The oceans would be heated and partially vaporized. Massive quantities of water vapor would enter the atmosphere. The surface temperature would become so extreme that the planet could temporarily resemble a molten world. The sky would be filled with dust, vapor, and incandescent debris. If you were somehow standing on Earth during the final moments, you would not see a giant blue planet slowly approaching you. You would see the sky itself becoming brighter and brighter and brighter. Then the environment around you would become unsurvivable. There would be no bunker deep enough, no building strong enough, and no technology capable of protecting humans from the planetary-scale energy released by this collision. But here's where the scenario becomes even more interesting. Would Earth actually be destroyed completely? Probably not in the sense of being blown into nothingness. Earth is held together by an enormous amount of gravitational energy. Completely dispersing the entire planet into space would require an extraordinary amount of energy. A collision this extreme could severely melt and deform Earth, strip away large portions of its atmosphere and surface, and eject enormous quantities of material into space. But some of Earth's mass could remain gravitationally bound. In other words, Earth might survive as a planet, but it would no longer be the Earth we know. The planet could become a hot, partially molten world surrounded by debris. The surface would be radically transformed. The atmosphere could be drastically different. The oceans might temporarily disappear into the atmosphere as vapor, and the familiar continents could be erased. But there's another question. What happens to Uranus? Because Uranus is moving at an absurd speed, the collision would dramatically change its structure and trajectory. Much of its material could merge with Earth's remaining material, while other parts would be thrown into space. Depending on the exact angle and impact conditions, a large amount of debris could remain orbiting the Sun. Eventually, some of that debris could collide with itself and form smaller bodies. Some could escape the solar system entirely. Some could fall back toward the newly transformed Earth. And some could potentially form a spectacular debris ring around our planet. Imagine Earth's night sky hundreds or thousands of years later. Instead of seeing a familiar moon, future observers might see enormous rings stretching across the sky, glowing faintly as sunlight reflects from billions of pieces of rock and ice. But life would face an enormous challenge. Complex life depends on stable temperatures, liquid water, and a relatively calm environment. A planetary collision would destroy all of those conditions at once. Plants would disappear. Animals would disappear. Civilization would disappear. The food chain would collapse. And the surface would become a place where survival was almost impossible. However, life on Earth has always been surprisingly resilient. Some microorganisms can survive in extreme environments. Deep beneath Earth's surface, microbial ecosystems exist far away from sunlight. If any life could survive the initial catastrophe, it would most likely be hidden deep underground or in extremely protected environments. Over enormous periods of time, the planet could begin cooling. The atmosphere could gradually change. Water vapor could condense. A new surface could form, and eventually, Earth might become habitable again. But it would be a completely different Earth. There is also an important scientific detail that makes this scenario even more fascinating. Uranus is not capable of simply being accelerated to 1,000 kilometers per second under normal solar system conditions. Planets naturally orbit the Sun at speeds measured in tens of kilometers per second, not thousands. Reaching 1,000 kilometers per second would require an extraordinary gravitational interaction, or some completely unknown mechanism. So this isn't something astronomers expect to happen. And thankfully, it doesn't need to be, because the real lesson isn't that Uranus is secretly coming for Earth. The lesson is how much energy is hidden inside motion. A planet doesn't need to be made of explosive material to cause unimaginable destruction. Give something enormous enough mass and accelerate it to an extreme enough speed, and the kinetic energy becomes almost incomprehensible. Uranus is normally a distant, frozen-looking world more than 1 billion miles from Earth. From here, it appears as a tiny point of light. But if you somehow turned that distant planet into a projectile moving at 1,000 kilometers every second, our entire planet would be forced to confront the raw power of physics. And perhaps the most terrifying part is this: Earth has survived enormous impacts before. Our planet's history contains collisions powerful enough to reshape its surface, alter its climate, and even influence the evolution of life. But an impact involving an entire planet at 1,000 kilometers per second would push that process to an entirely different level. It wouldn't just change civilization. It could change the planet itself. So the next time you look into the night sky and see Uranus as nothing more than a tiny, distant world, remember this thought experiment. That peaceful blue planet is actually a world containing more than 14 times Earth's mass. And if something could somehow send it toward us at 1,000 kilometers per second, Earth wouldn't simply have a bad day. Earth would become an entirely different world.